Hello friends, this is Balasubramani, Assistant Professor, RMD Engineering College. In this session, I'll be reading about the topic called as Karnaugh map in digital electronics. Now, why we should use Karnaugh map? We can use Boolean expressions, De Morgan's law, Cuttson's law, absorption law, and all these laws to obtain simplified expressions. But it's quite tedious. It's not easy. Moreover, it is error-prone. We need to simplify things. For that reason, K-map or Karnaugh map was introduced. Now, about the history, this so-called K-map was introduced by the person called Maurice Karnaugh in the year 1953. Now, what this Karnaugh is all about is, it is based upon mapping technique, a mind mapping technique whereby you can obtain simplified expressions. It's quite easy, it is moreover easy to understand. Now, let us proceed step by step. First, we need to understand first how many variables are involved for which we need to allot something called cells. Now, n, if there are n variables we need to simplify, then the number of cells we need to plot is 2 power n cells. The first instance, I am taking just 2 variables. So 2 power 2 is obviously 4. So that is written here. Now, 2 variables are set. What are those? Let me take n. These are the 2 variables in which we are going to process and simplify. Now, a and b are written here. 4 cells, it's appearing as if it is done in a square. Again, these are 4 squares. Appears quite simple. Next, we need to allot zeros and ones. That is what digital is all about. So, a in this direction, 0, 1. B in this direction, 0 and 1. When I have A and B variable together, then what are the combinations that I can get is 0, 0, 0, 1, 1, 0, 1, 1. So these are the 4 different combinations that I obtain when I am going to use 2 variables called A and B with the options zeros and ones. Now, whenever we are going to plot something called a logical diagram, we do it in something called as a sum of product form. That is, we use AND gate to obtain product term, and then this is summed up by using OR gate. This AND operation called as product term, in K-map we say it as min term, right? So this M stands for min term. Now, this subscript as such denotes the numbering what I have done. So M0, M1, M2, M3. What are those? Again, it moves in this direction. 0, 0. So its corresponding value is 0. So I have used the subscript called M0 here. Then 0, 1. The corresponding value is 1. So over here it is M1. Then 1, 0. 1 here and 0 here. So the combination is 1, 0. So 1, 0. The corresponding value is 2. So over here it is M2. Similarly, 1 here and 1 here. So 1 into 2 power 0 plus 1 into 2 power 1, that is equal to 3 in digital. That is to be precise, decimal number system. So over here it is 1, 1, it is M3. So I have marked here M0, M1, M2, M3. The 4 different combinations what are possible for a 2 variable K-map. So A, B, 0, 1, 0, 1. Things are clear? So these are the basics. So we need to get the basics clear before proceeding with few simple examples. I'm going to take 4 different examples for this 2 variable K-map. So step by step. The first example is this. Over here, it moves in this direction. Over here, A bar A, B bar B. I have marked 2 ones here. So the ones are supposed to be combined. How I am supposed to combine is, I can combine as 4 ones together or 2 ones together or a single one, it's a standalone. I cannot combine 3 ones because it has to follow something called 2 power n rule in digital. So I have combined 2 ones here in this digital movie. So this is B bar. Reason, this one over here it is A bar, for this one it is A. It is different. Whereas in this case B bar is the same. So I have combined these ones together and I have written here B bar. right? So that is how we are supposed to combine the ones together and mark the corresponding midterms. So three other examples to understand the concepts. The second example is this. I have placed two ones here to understand the concept. So again, A bar A, B bar B. So over here, A bar is pretty common. That is, the output is dependent on A bar and it is independent of A. That is the reason of me combining the two ones and writing it A bar. In the other perspective, I can say this is B bar and this is B. Both are different. Always when combining and writing the expressions, go for the term which is common, which is the same. So over here I cannot involve B bar and B over here. So A bar is common, so it is being combined here and is written A bar. The next example. So this is the case whereby I have all ones placed in the four sets. So if I'm going to combine as such, so it is dependent on A bar, it is dependent on A, it is dependent on B bar, it is dependent on B. That is the reason of me combining together and marking it as 1. Then the fourth example as such, over here I have placed a single one in this particular cell position. So this is A bar, this is A, this is B bar and this is B. So in this particular position called as M1, I have placed a 1. I need to give an expression to it. So I have do it. So this one, this particular term over here, literal, this is called literal and digital. This is called A bar. This particular literal is called as B. So I need to combine these two. A bar dot B. So this is how you are supposed to write the simplified min term for this one. So this concludes our part 1 discussion of Cayman. Thank you.